Hello, welcome to our channel for probability and statistics. In this video, we will talk about tests for independence using chi-squared test. So we know sometimes we want to test the independence of two categorical variables, and in this case we can use chi-squared test. This is also a special case of the goodness of fit test. So we show an example. Suppose that we wish to test whether the opinions of the voting of the state of California concerning a new tax reform is independent of the people's levels of income. So we take a sample, 1,000 random sample from the state, and we get the values for their income, low, medium, and high, and we also get their attitude towards the favoring of the tax reform. So this table is the opposite of the data. There are six cells for the counts for each category. For example, this is for the vote and with the low income people. These are against the vote and with the medium income, and so on. And this is the marginal for the row, and this for the marginal for the column. And this is the total observation number, 1,000. So the sum of the marginal will equal this number. It's a very simple and clear table. This is also called contingency table for the two categorical variables with respect to their values. Then our decision is to accept or reject the null hypothesis. So in hypothesis testing, we have null hypothesis called H0. And here the H0 is we will test the independence between the voter's opinion and their levels of income. So we get the data between the observed for the observed data, and we want to test if the observed data matches the frequencies of the expected data. So what is expected data? Expected data is if the assumption that H0 is true. So if there is independence between these two variables, between the income and the opinion vote. So we can get expected frequencies for each marginal. And this is for the person in the low income. This is for the person in the medium income. And this is for the person favor the tax reform. And this is the person against the tax reform. And these five categories, each is this marginal level, right? So we can get these marginal probabilities just using the marginal number divided by the total counts. So this is expected marginal proportions if the null hypothesis is true, if there is independence between the two variables. So these are marginal probabilities. So next, we can get the expected cell number, or say the expected frequencies for each counting in each cell by multiplying two marginal probabilities. So we look at this table again. So for example, for this cell, people against and with the low income, we just multiply these marginal proportions with these marginal proportions. And these proportions actually is this marginal number divided by the 1,000 total counts. Same for this one. So for each of these six cells, we can get the expected counts or the expected frequencies. This is the result for both observed frequencies, observed counts, and expected counts, expected frequencies, which stay in the parentheses. So next we can test the null hypothesis of independence using chi-square test. So first we have to calculate a test statistic from observed value and expected value. So it's quite simple. It's just a summation of all observed value minus or the difference between observed value and expected value, then take a square, then divided by the expected value for all the cells in the contingency table. And if the null hypothesis is true, this statistic will follow a chi-square distribution with R-1 times C-1 degrees of freedom, where R and C are numbers of the columns and the numbers of the rows. And this is a density for the chi-square distribution, probability density, and this value is called critical value for the chi-square alpha, which means upon this value, the probability leave to the right of this value is alpha. So in a chi-square test, usually we set alpha is 0.05. It's a very small probability compared with the total probability 1. So if we get the sample statistic chi-square larger than this value, we will say the test is significant, or we will reject the null hypothesis that the two variables are independent. Otherwise, if we get the sample statistic less than this critical value, or say test statistic stay in this white area, then we will not reject the null hypothesis, and we will say we hold the null hypothesis that the two variables are independent. So for this example, we can calculate the test statistic chi-square equals 7.85. And from the chi-square distribution table, we can get chi-square 0.05 equals 5.9091 for 2 degrees of freedom, because 2 rows and 3 columns in this table. So because 7.85 larger than this critical value. So in this example, the null hypothesis is rejected. And we conclude that the voter's opinion concerning the tax reform and his or her level of income are not independent. Thanks for watching.